Hi all. So today we are going to demonstrate the following topic, that is how to use a VirtualBox to create multiple VMs and connect these VMs and host one microservice-based application. In order to achieve this, we will be using Oracle VirtualBox and Ubuntu 24 LTS version as the OS in both the VMs. And we'll create a very basic Node.js microservice and deploy in both the VMs and communicate that will communicate with each other. So let's get started. And as the first step, we need to download the following things like Oracle VirtualBox. We'll see this link coming up. From here, we can download for the respective OS. In my case, it's Ubuntu Noble. So I'll download this deb package, and it's already downloaded for me. So I'll just show. So you will download a file similar to this. And if you click on this, it will open up a install package option over here. Since mine is already installed, it's showing reinstall or remove. So you need to install it. And once it's successfully done, uh, you will go to the search and type Oracle, and you will find that Oracle VirtualBox will be like this. And if you click on it, so you will get an interface similar to like basically these things are already there because I've already created some VMs. Otherwise, it will be a blank page. And from there, you need to use the new option to create the VMs. So before we get there, we need to do another thing, that is download the OS ISO. So in our case, we will be using Ubuntu OS, and this link will go download Ubuntu desktop. For me, I have chosen 24 LTS. Once you download this, similarly, this ISO file will be there. Now we'll look into the steps how to create the VMs. So for that, we'll click on new. There we'll give some name like demo VM, and we'll select the ISO image going to the location, click and open. So it's automatically taking the other options. Here in the unattended install, you will find, you'll just check the password over here. Hardware allocation, I have checked like 2 GB, and processors, one CPU is by default. I generally increase to 2. It's up to you, depending on the configuration of your machine. Hard disk also, like by default 25 GB, I keep it as it is. And once I finish this, actually it will start the VM and the installation process of this Ubuntu OS. So as we can see here, the installation is in progress. So after this completes in this VM, it will come up similar to the VM I created. So this screen will complete and then the installation will finish. So after you are done with both the VM creation, we can then proceed to the next step, that is the creation of a microservice and how to deploy it. So that's it from this one. Hi all. So since we have now created both the virtual machines on Oracle VirtualBox, so we'll start with trying to connect with each other, like pinging from one VM to other. So we are confirmed that the connection is established and there is no firewall interfering between them. And then only we'll go into the microservice creation and its deployment. So first of all, we need to understand the IP addresses of both the VMs. So after you have started both the VMs, similar to what I've done. So this is my VM1 and this is VM2. So I've opened side by side. I'll just open the terminal in the first one and type IPA. This will give me the list of like network details. And this here you can see, this is my IP address. And similarly for my VM2, I'll get like this is 10.0.2.4 and this is 10.0.2.5. Now we'll try to ping VM1 from VM2. So for that, I'll type ping 10.0.2.4. So as you can see, there are bytes transferred. So the ping is working. That means uh, the VMs can communicate with each other. So we are good here. As the next step, we now need to start installing the dependencies before we get started with the microservice creation. So installing Node.js and NPM will be the first step since we are creating a Node.js microservice here. So let's get started. I'll type sudo. First, I will update my package list. We'll use the -y command so that we don't have to again and again give the yes. Let's try to install Node.js. Node.js and npm. Okay, so once we have installed Node.js and npm and any other dependencies that are needed for the microservices, now we need to go and create a microservice application. So I'll open the terminal in VM1. I mean, you can create this microservice in your host machine also and then deploy it in the VMs. That we will see later. But first, let's do it inside the VM only. So, so ideally, we will first create a new directory and maybe we can name it something like uh, new service. Then we get inside this directory. So we'll initialize the Node.js application with the init command that comes from npm. We'll put the Y flag as well so that we don't need to again. Okay. So once the project is initialized, we then need to install Express because we will be using Express library to make our server, Express server rather. It gives us some built-in features. So we'll install Express. So Express is now added to our project. And then we will write our microservice code. That's a very simple hello world service we will write up in Node.js. So let's start with importing the dependencies. So Express is the first one. Okay. Then we'll declare the Express server. We'll create an instance of the Express server rather. We will declare a port to be used throughout our application. Let's take 3000. Now we'll create a get API. So this will be our async function, or the promise rather, that we will be returning from here. It's an arrow function, JavaScript arrow function. Basically, it runs in a different thread. That's it. Simple layman terms. So response we are returning from this promise is in a JSON format. So, so JSON means JavaScript object notation. Let's say Ubuntu 1 for me. Okay. Then that's it. This one we will return from here and close this API structure. Now we will start the server using app.listen function. So we will be listening our application in the port we mentioned above, and the IP, it will be, so the local IP of this 0.0.0. And then clear the arrow function. If we want to do any additional stuff when the app starts up, so on app startup, rather service startup, we'll show a console log saying the app is now running. Server running on HTTP 0.0.0. Fetch the port from here. Close this console log. Then we will, let's put some tab space here so it's well formatted. Now we'll save using Control X, Control Y, and write it to this index.js function. Index.js file, and save it. That's it. Our server is ready, and we can now start using node command and write the file name, which one to serve. So node index is, as soon as we start, that console log is printed. So the server is running now. Uh, so half of the job is done. Now we need to hit this API from the other VM. So let's go to VM2. We log in here, open the terminal. So in order to hit the API, we will use curl over here. So install curl. I guess it's already installed, so it's saying that. Now we will use the curl command to hit the API from this service, the service that is running in the VM1. So for that, we'll use curl and then the address of that service, the endpoint rather. So our IP for VM1 was 10.0.2.4, if we remember, and then we'll get the port where we are running it. Ideally, it should return this message over here that we mentioned in the index.file. So let's see. Well, it's working. So message hello from Ubuntu 1. So a new line character is not there. So that's why it's in the same line. So the JSON response we get, so we are successfully able to hit the endpoint running in the other VM from this VM. So that's it for this video. in the next video, we will try to optimize this solution further, where we will deploy this service in both the VMs using Docker. And then we will try to hit it from other VM. Thank you. Now, since our microservice is up and running in Ubuntu 1 VM, and we are able to communicate it from VM2, so we'll go one step further and containerize the microservice using Docker so that we can utilize both the VM's potential and like deploy two instances of the application in the two VMs. So first of all, I'll stop the current running service, Control C, and I'll start with the Docker installation. So since Docker is already installed in my system, I'll just show the command that is needed. So it's sudo apt install y docker.io. So it's already there. And then we need to enable the Docker, like start the service systemctl. That's the why it's needed. Enable now Docker. So this is the second command we need to run. I'm not running this because it's already running for me. So once your Docker is up and running, you need to create a new Docker file inside your like here inside your application directory using nano. You can manually also create in the graphical interface, but let's say we are creating nano Docker file. I've already written the Docker file code here. So we are first pulling up the dependency. So the real essence of Docker is to streamline the process of deploying services in various environments. It doesn't matter what's the hardware, like what's the configuration. So it will have its dependencies in the image. So it standardizes the process and maintains a consistency for the development. So if my machine is able to run an application like on Docker, so the same thing will run in the test environment, production environment. So that's why we need it. So first we are importing Node.js, Node 18. So, and there inside it, we will create a work directory like app and copy package JSON from our directory because that is what's needed mainly. It describes the dependencies of our application and also the index.js file. We will then ask Docker to run the npm install and download all the dependencies inside the image when it's building it, and then copy the resource in the files, and we'll declare which port we will expose our application. And finally, the command, Docker command, what we want Docker to run when we are running the image. So it will be node, since it's a Node.js service, it's node index. It's the same command we are using in our terminal to run the service. So I'll just save this as it is. Now let's build this Docker image. For that, I'll be using this Docker build tag, short form tag, new service dot. This is important, otherwise it will fail. So it started the build process and it's built the Docker image. Now we want to run the Docker image that has been generated in the container. For that, the command is sudo run the port we will mention here 3000, and the name of the image that the tag we mentioned. So it will be able to understand because we can have multiple images generated from the same system. So let's see. So it generates a GUID, but inside it's running. So Docker is running. If we do a IPA here, we'll see that there is a Docker running in the background. So we can test this out now using the curl command in our second VM. So I will just hit enter because, yeah. So if we hit the endpoint from the VM again, it's the same response. So that essentially the service is running properly for us. So that's it, guys. This is how you can build, like you can deploy application using a Docker image, first building it. In the next part, we will see how we will use a load balancer. First, we will deploy this Docker file, Docker image to the Docker hub and pull it from both the VMs and deploy it there. And then we will create a load balancer to utilize both the VMs resources. Yeah. Okay, so as a next step, we are now going to create an account in Docker Hub. As you can see here, I've opened Docker Hub and we will sign up here. And so I already have created an account. So I'll just log in. You can create using Google or GitHub. I would say that set a password, reset your password once you are done, because you will need that in the command line when you log in from your terminal. So once you are registered in the Docker application, you can deploy your, like, you can push your Docker images over here and then pull it from anywhere and run it. So that's a big advantage. Now I'll just close this window and go back to my VM1 where I built my Docker image and tested it. So first thing we need to do is Docker login from here, from the terminal. I think I'm already logged in. So yeah, so I am already logged in. It's not asking for my username. Otherwise, it will ask your username and password that you did on the website. Once you are done with that, you need to now push your image to the Docker Hub. For that, the first command will be sudo tag. You need to give the same tag like new service, then your username or the Docker Hub. For me, it's shown in 00, and then slash the name which you want to give to your service, and then the version or the tag you are giving. So it's already, I have already done this step. I won't repeat it. I'm just showing the first command. Once this is done and successful, then you need to use Docker push. So that command will be, so Docker push, and then username slash the same thing, new service or latest. So after you do this, it will take some time to upload your image. Yeah, so like this, it will upload. It says already exists because I already pushed it. There is no change, that's why it will not upload. Now, once this is done, what you can do is you can pull this image and just run it. You don't need to write the application, or like you don't need the code. So first we'll delete our existing application, or rather uh, we'll just we'll just not open or run it here. We'll pull the existing Docker image from the hub. So in order to do that, we have a command called, okay, before that, let's check whether that image is there or not. I'll just go to my Docker hub. So as you can see, there is this image. 1 minute ago, I uploaded. So it has the latest one. Yeah. So now let's go back to our VM. And We'll use the Docker pull command now. The Docker username and the same thing, new service latest. So as soon as we click this, so it has pulled it successfully. Okay, so now that we have pulled the Docker image in our VM1, let's try to run the same using the Docker run command. So we'll use sudo docker run. Now this will be a bit different because this is a pulled image. So it's not our local image. So we need to first mention the port. Then we have to give our Docker username, Docker Hub, and the service name and the version. So now it's up and running. We will just verify once by going to the browser in the VM1 before we will hit the API in the other VM. So see, we are getting the response, hello from Ubuntu 1. Now, if we check from here also, we'll get the response. So it's working. So we are able to pull the Docker image in our VM and run it. We will do a similar thing in our VM2. Okay, so since we have now started the microservice in both the VM1 and VM2, like the Ubuntu 1 here and Ubuntu 3. So both are running a Docker image of the same microservice. Now we are going to install and configure the load balancer in a separate third VM from where we will request only to that load balancer, and that load balancer will decide on a robin algorithm to which VM it want to redirect the request. So let's go to the Oracle VirtualBox, and I have already created another VM. So I'll be opening that. Okay. So this is the third VM I created, and here in order to configure, we need to install Nginx. So Nginx is like it will a library that will help us. Is a package rather help us do the load balancing part for us. So first we need to add that install Nginx. So since it's already installed for me, it's showing like that. Now we need to next configure the Nginx. For that, we will have to edit the config of the Nginx, which is present in the etc Nginx folder .conf file. So I'll open that. And here I've already added the configuration actually. So we need to add this section upstream and name a cluster or backend cluster of backend servers we need to add. Inside that bracket, we'll mention two of our VMs IP addresses along with the port, basically our services and their addresses. So these two services, it will be managed by this load balancer. And we will mention a server section here where we will mention the port where the load balancer will run in the, it will run in the default port, and then server name. And finally, we will add a location as like the paths which we want to access and the proxy. So in the proxy path, we will add the address of our load balancer, like cluster. So this is the configuration we will do. And additionally, I have done a logger configuration here, log format. So which will print which server IP address the request was sent in the upstream address, and we will be using for this particular server, this is our log configuration. The upstream log we mentioned above is used here so that we can track whether the load balancing is working or not. So I won't change any configuration from here since it's fine. I'll just test whether this configuration is working fine or not with this command. So after you change something in the config, you always need to do a validation. So this is the command. It says it's successful. And once you are done with that, you will need to restart the basically engines once again. So this is the command for that. So now the load balancer is working and started running. We need to test it out. So for that, we will use a constant API request in a looping format. We'll use a loop of curl commands to our load balancer API. So this is the API. This is the IP address of the load balancer. I'll just confirm once again. So as you can see, 10.0.2.15, and we will hit it in a constant interval. So this will keep on hitting it. And now in a different terminal, I'll open the logs. So for that, this command we will use. So as you can see that there is a random, like first it is hitting 10.2.4, then 10.2.6. So it's distributing the request. And this is how the load balancing is working. The more number of VMs we keep on adding in this configuration, so Nginx will automatically keep balancing the load and distribute the traffic. And we can customize those algorithms also. By default, it's round robin, but we can also use some other algorithm that's present in the documentation of Nginx. So this is it, guys. We come to the end of the entire demonstration. This is how we configured our microservice and deploying it in two VMs, and using Docker, we were able to generate an image and then deploy directly, and we used Nginx for load balance. Thank you.